Hello everyone, I am Dr. Prem Kumar, Associate Professor, Department of CSE, ACE Engineering College. In today's session, we are going to discuss about software engineering, the importance of software engineering. First of all, what is software? A software is a set of items and objects that form a configuration that includes programs, documents, and data structure. Any software is a collection of programs, right? And any software can be represented in the form of documents, that is in the form of procedure, which will help to the users how to use the developed software, and data structure, which is used to store the data and which is used to organize the data. That is what the importance of software. So any software which consists of set of programs, programs is nothing but set of instructions, right? And documents about the program, procedure in the form of documents, which will help to the end users how to use the developed software, and data structure which stores and organizes the data. That is the importance of software. Software which consists of programs, documents, and data structures. This is what graphical representation of software, right? So software is a combination of programs plus documents plus data structure. Right? Software consists of the following. What are the things where any software which consists of? That we'll discuss. So any software is a collection of source code. So who will generate source code? Programmers, they'll generate source code, right? So any software which consists of source code. Once they generate source code, generated source code is supposed to be executed and executable file will be created, right? And any software, right, which consists of user manuals. What is the need of these user manuals? Why user manuals requires for the clients, right? Let's take the user, they purchased, for example, they purchased mobile phone. How to operate that mobile phone? That is in the form of user manuals will be provided to the mobile users. Based on the user manuals, they can learn and they can operate the mobile phone efficiently. That is what the purpose. Similar way, any software which was developed by the software engineering team and going to deliver to the client, right? So that software consists of source code, and the team, software engineering team, going to provide user manuals to the client, right? So the user manual which consists of how to use the developed software, right? Installation manuals. If the client is interested to install the developed software in their machine, then how to install it? Installation manual which consists of procedures for how to install the developed software in the client's machine. That is what the importance of installation manuals, right? Next is of executables. Just now we had discussed. Programmers, they had generated source code, right? Once it is executed, right, which is going to create executable files, right? So any software which consists of source code, user manuals, installation manuals, executable files also, and which consists of requirement analysis and design documents. We know the importance of requirements. Who will provide requirements? Clients, they will provide requirements for development of any software system. When clients provide requirements, the gathered requirement might have contradiction, ambiguity, incomplete requirements. Those supposed to be analyzed. This process we call it as requirements analysis process, right? And design document. Based on these requirements, after requirement analysis, one document will be prepared. That is SRS document. Based on this design document, so design will take place. So design means preparing blueprint for the software system. So this requirements analysis and design documents, which will helps to the clients to better understand the delivered product to them, right? Next, types of software. So softwares were classified into various types. What are those various types? That which we are going to discuss, right? So there are many different types of software. One of the most important distinction is between custom software, generic software, and embedded software. So we are going to discuss about 3 types of software. There were many types of softwares. So first one is of custom software. Second one is of generic software. First one is of custom software. Second one is of generic software. Third one is of embedded software, right? So what is the importance of this custom software? The importance of this custom software, which is developed for the specific need of a user or client. So custom softwares were developed which is used to satisfy the specific need of a client or specific need of a user. The example for this custom software is of creating websites, air traffic control systems. All these comes under custom software. That is the importance of custom software. Then what is the importance of here generic software? Generic softwares were which were used for multiple purposes for the multiple clients. The example of generic software is of Microsoft Word, spreadsheets, compilers, operating systems. All these comes under here example for generic software. Generic softwares were developed for multiple user purpose, right? So once operating system, compilers, right, spreadsheets, right, Microsoft Word, which is those softwares were created. That means to say in the open market, anybody can purchase, anybody can use those softwares. Such type of softwares, we call them as what? Generic software. That is the importance of generic software, right? And coming to embedded software. So what is embedded software? What is the importance of embedded software? That which we need to discuss, right? Embedded software runs specific hardware devices, right? So embedded software here in hardware devices, inside of hardware devices, some softwares will be installed. Such type of softwares we call them as embedded software. Example for embedded software, right? So there are various devices. What are those here is washing machines is the best example for embedded software. DVD players, microwave ovens, and automobiles. Even mobile phones also the best example for what here? Embedded software. So mobile phone. So outside hardware layer, hardware, inside some softwares, is it? So Android operating system and all which will be installed in that particular software. So all those comes under embedded software, right? Next we are going to discuss about the nature of software. Nature of software. So what is the nature of software? That we'll discuss. So simply we call it as what is the characteristics of software, that which we are going to discuss. Software is developed or engineered but not manufactured. That is one of the characteristics of software. What is the first characteristics of software? The first characteristics of software is developed or engineered but not manufactured. That means to say software can be developed by software engineering team, which can be engineered, designed by software engineering team, but softwares cannot be manufactured, Then what can be manufactured here? The hardwares can be manufactured. Softwares cannot be manufactured. Software always developed, engineered, whereas hardwares can be manufactured, right? Now observe carefully here. Failure curve for hardware. What is the failure rate of hardware comparing with software? That which we are going to discuss. That is the nature of software, difference between hardware. So how frequently the hardware is failed and failure rate, is it hardware more or software more? That we'll discuss. Now this particular figure diagram represents failure curve for hardware. Now observe carefully. So x-axis represents time, when time increases, right? So here failure rate of hardware also increasing here, and this is what x-axis. Y-axis represents here failure rate. Y-axis represents failure rate. Now observe carefully. Initially the hardware failure rate is too high. Hardware failure rate is too high. What is the reason here? The hardware components, right? Is it hardware design components, development components, which were having more defects in it. Defects is nothing but what? Errors or bugs in it, right? Errors or bugs in it, right? So that means to say at initial stage, hardware failure rate is too high. When the hardware components, design components, manufacturing components, bugs and defects were detected slowly, then the failure rate is what here? Decreasing. At certain period of time, the hardware failure rate is maintaining consistency. And after some time, after some months or after some years, right? What will happen? Hardware failure rate is again increasing. What is the reason behind this? hardware components were affected by the environmental melodies. Environmental melodies. Environmental melodies. Hardware components were, is it, affected by environmental melodies. That means to say, on hardware components, environmental melodies. What are those here? Dust, vibration, right? Extreme temperature, extreme temperature, extreme temperature, etc. All these environmental melodies can affect the hardware components, hardware devices. Due to that, failure rate of hardware is becoming too high, that is wear out. As it software does not wear out, where hardware is wear out. Why hardware is wear out? The reason here is environmental melodies which will affect on hardware components. Due to that, hardware components failure is too high. Is it? So this is what the failure curve for hardware. Failure curve for hardware. Next we'll discuss failure curve for software. So software does not wear out. Just now we saw software does not wear out. That means to say, which one is wear out here? Hardware wear out. That means to say, environmental melodies which will affect on hardware components. Due to that, hardware components can be damaged. That's why hardware failure rate is too high. Hardware is wear out, whereas software does not wear out. That means to say, environmental melodies will not affect on software. Environmental melodies will not affect on software, right? So that means to say, extreme temperature, dust, vibration, all those environmental melodies will not affect on software, right? So that's why observe carefully. This is what the actual curve. Initially, the software applications are programs, right? As it are projects which might have more number of bugs in them or errors in them. That's why failure rate of programs is too high. When those program errors, bugs were detected, then failure rate is decreasing. Failure rate is decreasing, and slowly, which is little bit increasing. This is what actual curve. That means to say, failure rate of software is very less than the failure rate of hardware. Why? On software applications or programs or project, environmental melodies will not affect, right? So this is what the actual curve, right? When here failure rates of programs were more simplified, more bugs, errors, defects were simplified, detected, is it uncovered? Due to that, what here? The failure rate of software, is it, which is maintaining idealized curve. That means to say, failure rate of software is very less because no environmental melodies will affect on software. So this is what the diagram represents failure curve for software, which is less. Failure curve for software is very less than the failure curve for hardware. So these are the characteristics. These are the characteristics. Although the industry is moving toward component-based construction, although the industry is moving toward component-based construction, right? Most software continues to be custom built. So we know what is mean by component. What is mean by component? Physical replaceable part of a software system is called as component. What is component? Physical replaceable part of a software system is called as component. Physical replaceable part of a software system is called as what? Component, right? So components were small in size, right? And so that the designers and developers, they can easily design and develop the components. Components were easily reusable because of small size, easily replaceable, easily manageable. That's why component-based development became popular in software industries. But most software continues to be custom built. So custom built example of components here, cards. So commercial of the self components. Commercial of the self components. So ready-made components, built-in components, which can be easily reusable in the newly proposed projects, so that the development time, development cost will be reduced. So this is the one more characteristics of software, right? So next we are going to discuss about legacy software. What is legacy? That we have to discuss. What is meant by legacy? Old. The meaning of legacy is old. What is legacy software? Very, very old softwares are called as legacy software. What is legacy software? Very, very old softwares are called as legacy software. Very, very old softwares, right? So very, very old softwares are called as legacy software, right? Then software must be adapted. Old softwares must be adapted to meet the needs of new computing environment. That means to say what here? Software, old software supposed to be adapted to the new computing environment, has to satisfy the new computing environment requirements, right? Software must be enhanced. Enhanced means what here? Old software is supposed to be improved to implement new business requirements. So client requirements were changing frequently, right? So whenever the new requirements come into the picture, based on that, already existing old software supposed to be improved so that new business requirements which is given by the client can be satisfied, right? Next is software must be extended to make it interoperable with other model system. Software must be extended. So the old software is supposed to be extendable. Is it supposed to be elaboratable? Supposed to be, is it extendable? Means, is it so that which can communicate with other already existing software systems and which can work with other systems. So this is about legacy software. Software must be re-architected. So what is the need of re-architected? Because the legacy softwares were already existing old softwares, right? So for example, those old softwares were not meeting the current need of the clients. So new business requirements. What is the solution for that? The already existing old softwares architecture supposed to be re-architected, means the already existing architecture of the old software supposed to be what? Modified, so that which can reach the new business requirements of the client. So that is what very, very old software supposed to be what here? Supposed to be adaptable, supposed to be enhanceable, supposed to be extendable, supposed to be re-architected so that which can work based on the new business, new client requirements. Next we are going to discuss about software engineering. So our subject, our course is of software engineering. So what is the importance of this particular subject? So this one of the core subjects, software engineering, right? So any software engineer, if they want to develop a software system, they have to follow software engineering principles, software development lifecycle models, software development lifecycle phases, that's it. So that's why software engineering plays major role, right? So what is software engineering? So what's the importance of this particular subject, right? That we'll discuss. Software engineering. Software engineering. Software engineering is the application of a software engineering is the application of a systematic, disciplined software engineering is the application of a systematic, disciplined, quantifiable approach to the development of software application or project and operation of developed application or project, maintenance of developed application or project. So that is what the importance of software engineering. Software engineering is the application of developing the software application systematically, developing a software application disciplined way, developing a software application quantifiable way, so that the development, operation and maintenance of the developed software application which can be easily usable by the end user. So if the development is systematically done, disciplined way and quantifiable way, right? so that the end users, they can easily operate the developed software application, is it? And in the maintenance of software application also very easy. So this is what the software engineering, which helps to the software engineering team to develop a systematic, is it, disciplined and quantifiable approach for, is it, for development of any software application or project. That's what the importance of software engineering. So what is the outcome of the software engineering? Software engineering is an efficient and reliable software project. The outcome of the software engineering is what here? Providing efficient and reliable software product. Reliability is nothing but what here? The developed application which is delivered to the client, when the delivered application is under operation by the client, which has to provide continuous services to the client without fail, that we call it as reliable software product. So which is possible by software engineering, right? So the developed and delivered product, is it, which is providing efficiency as well as reliable software product services to the end user. So that is possible by software engineering. That is the outcome of the software engineering, right? Next is software development life cycle phases. So what are the various software development life cycle phases that we'll discuss? What are the various software development life cycle phases that we'll discuss, right? So there are various software development life cycle phases. Any software engineering team, if they want to develop a software system, software application or software project, they have to follow this software development life cycle phases. Based on these phases only, any project development will take place in software industry, right? So that's why software development life cycle phases plays major role for development of any software system. So based on these phases only, any software engineering team, they'll develop a software projects, right? So first phase of software development life cycle phase is of planning and risk. So before going to develop a software system or software project, right, planning should be taken place. Who will plan about the project here? Project manager. Project manager is going to plan about the software project. So what is planning represents here? Planning represents here, project manager going to plan about the budget of the project, budget, schedule, and manpower, etc., resources, many other things, right? So planning about budget of the project. So before going to develop a software project, right, the project manager has to prepare the project plan, which consists of how much budget is required for development of that particular project, how much duration is required, can we complete the project within 1 year? So schedule is supposed to be prepared by the project manager. And manpower, how many software engineering teams has to work to complete this project. So this is what the plan of project consists of. Project planning consists of all these details, and project planning can be done by the project manager. Once this project plan was prepared by the project manager, once this project plan was prepared by whom here? Project manager. Once this project plan was prepared by the project manager, right? Then, right, based on this project plan, the software engineering team, they have started development of what here? Project development of project is under progress, right? Then when the project is under progress, they come to know that the initially already planned project plan, already some budget was allotted, schedule was allotted, manpower was allotted. When the project is under progress, the software engineering team, they come to know that the already allotted, what we call it as budget related risk. We cannot deliver the project within 1 year. 1 year was already planned by the project manager. We cannot complete the project within 1 year. We cannot deliver, right? That is risk related to schedule, right? With 5 members team, we cannot complete the project, right? So that is risk related to manpower. So these are all, we call them as risk. Those risks should be managed, this should be resolved, right? That we call it as risk management. It means adjusting the budget, adjusting the schedule, adjusting the manpower. So risk should be identified, risk should be resolved, risk should be managed. That is what planning and risk. First phase of software development life cycle. What is the second phase here? Second phase, requirements and analysis. For development of any projects, right? For development of any projects, who will provide requirements? That's your question, right? So always project requirements will be given by the clients. Clients, they'll provide requirements. Clients will provide requirements. Project analyst directly goes to, where here? Project analyst directly goes to client company, and gathering the requirements for development of software system. The gathered requirements might have what here? Contradiction in it, ambiguity, and incompleteness, right? So through analysis process, the gathered requirements might have contradiction in it, ambiguity in it, incomplete requirements, erroneous requirements. Those gathered requirements, through analysis process, contradictory, ambiguity, incomplete requirements will be discarded. After discarding all these contradictory, ambiguous, incomplete requirements, one document will be prepared. So useful requirements, with the useful requirements, one document will be specified. The name of the document is what here? The SRS document. So what is here? SRS stands for? SRS stands for Software Requirement Specification. Software Requirements Specification. Software Requirements Specification. SRS stands for what here? Software Requirements Specification, right? So let's take here, for example, the client is given how much here? So project analysts gather, for example, 100 requirements. After analysis, after applying analysis process, right? 70 requirements were useful for development of software system, whereas 30 requirements were contradictory, ambiguous, incomplete requirements. So these, through analysis process, these 30% requirements should be discarded. Contradictory, ambiguous, incomplete requirements will be discarded. Only 70 requirements were useful for development of software system. With these 70 requirements, SRS document will be prepared. Software requirement specification document will be prepared. What exactly this SRS document consists of? SRS document consists of client requirements, user requirements, system requirements, project strategy, means project plan. That is what the importance of SRS document. Once the SRS document is prepared, then based on this SRS document, design will take place. So in which phase solution will be given, right? So in design phase, solution will be given by the software designers. Software designers, architecture level designers, they are going to give solution for the software system. So what is design represents here? Preparing blueprint for the software system is called as design here, right? Preparing blueprint for the software system is called as design. So architecture level designers, they are giving solution based on the SRS document. So that is what the importance of design. Once the designers, they have designed a software system, they prepare blueprint and they prepared blueprint, and afterward they prepared one document. Name of the document is SDS document. Name of the document is SDS document. What this SDS stands for? Software Design Specification Document. Software Design Specification Document. What this SDS document consists of in it? This SDS document consists of right, pseudocode or algorithm, DFD, data flow diagram, or UML, Unified Modeling Language, right? So this SDS document consists of pseudocode or algorithm, DFDs or UML, right, which consists of backend database. And there are many backend database, MySQL, Sybase, and MongoDB and MongoDB, etc. Right? So these are all the STS document consists of, right? So pseudocode or algorithm, design part. So design of a software system by using DFD, data flow diagram, or else UML, one of the object-oriented programming, object-oriented modeling language. UML represents unified modeling language, which is used to model a software system, right? And which consists of backend database, right? So that is what STS document consists of, right? What is the next phase here? Coding. Who will generate source code? Source code can be generated by the programmers, software developers or programmers. They'll generate source code. Based on this STS document, source code can be generated by the programmers, right? Source code can be generated by the programmers by using one of the implementation languages. So there are various implementation languages, procedural oriented languages, object oriented languages, right? So one of the object oriented language was it, the programmers, they had used one of the object oriented language and they had generated source code. The generated source code might have what here? Various errors in it, syntax errors, semantic errors, logical errors, processing errors. So which process going to detect all those errors, to identify all those errors? For that, one more software development lifecycle phase here is testing will take place here. What is the purpose of testing? What is the source code which is generated by the programmers, which might have syntax errors, semantic errors, logical errors, processing errors, right? Those errors supposed to be detected in this testing phase. Who will perform testing here? Software testers. Software testers, they'll perform testing process. Testing can be done two ways here. One is of manual testing. Next one is of automated testing. Manual testing, is it? Automated testing. So what is manual testing? So testing process can be done by the human being, that we call it as manual testing. Then what is automated testing? Instead of human being here, software testing tools, can perform testing process. That is what automated testing. Which one is better here? In manual testing, which is time consuming, and here budget also required more, is it? Manpower also required more. Those are the drawbacks. That's why automated testing became popular. Nowadays, almost all the software industries, they are using automated testing. By using tools, they are performing testing process. Why? The advantage with tools here is it? So testing, the tools, without human intervention, tools can perform testing process, which can identify errors, is it? And testing tools can perform testing process day and night, in holidays, Sundays and all. So the time required for performing testing process here is less, even the budget also less, manpower also less. These are all the advantages with automated testing. Right? Once the testers, they perform testing process, they identified errors, they prepare error report that is given to whom here? Again to developers or programmers. They'll perform debugging process, correcting those errors. Now the application is error-free. Our project is error-free. Once the project is error-free project supposed to be deployment. Deployment is nothing but delivering product to the client. Deployment is nothing but what here? Delivering product to whom here? Client. Once the product is delivered to the clients, they'll evaluate the product, right? If the delivered product is based on their expectation, based on their requirements, based on their needs, they'll give positive feedback. If they identified any minor changes, those minor changes will be, will be given to whom here? Maintenance team. Maintenance team going to correct those minor changes. Again, redeployment will take place. Is it? Again, the client, they will evaluate. If they satisfy, the process will stop. So this is what the importance of software development life cycle phases. Software development life cycle phases. Right? Next, we are going to discuss the software process. So what is the importance of this software process? That we'll discuss in detail. What is the importance of software process, right? A process is a collection of activities, actions, and tasks that are performed when some work product is to be created. So what is a process? A process is a collection of activities. Means here activity is nothing but what here? Communication between client and development team. Why communication required between client and development team? Because client development team has to gather requirements from the client to develop a software system. That is what activities. Then what is here? Actions. That's it. So actions. So here architectural design will take place. That is what we call it as actions. Then what is your task here? So task means here conducting unit testing. What is unit testing here? First of all, what is unit? Small piece of a software source code. So testing that small piece of a software source code and identifying bugs, that we call it as task here, right? So a process is a collection of activities, actions and tasks that are performed when some work product is to be created, right? An activity strives to achieve a broad objective. What is that objective? Communication with stakeholders. So clients has to communicate, clients and developers has to communicate so that developers can gather the proper requirements from the client. Based on that, development of software system will take place. Next is an action. So architectural design encompasses a set of tasks that produces a major work product, that is an architectural design model. So model of a software system, design model of a software system will take place. Design model of a software system will take place, right? Then a task focuses on a small but well-defined objective. That is what conducting a unit test, right? So unit test. Unit is nothing but small piece of a software source code, testing that small piece of a software source code, identifying errors, that's it, and correcting those errors. That is what the importance of what here? Task. Right? All these are the part of what here? Process. A process is a collection of all these things, activities, actions and tasks. What is the intent of this process is always to deliver software in a timely manner and with sufficient quality to satisfy the customers, right? So next we are going to discuss here software process with diagrammatic representation. Let's see here. A software process which consists of process framework. Again, process framework is a collection of what here? Framework activities and umbrella activities. Umbrella activity is a collection of framework activities. Umbrella activity is a collection of framework activities. So framework activities 1. So what these framework activities consists of? Work tasks, work products, milestones, deliverables, quality assurance checkpoints. So what is here work tasks? Work task represents here communication between client and developers to gather the requirements. So that is what one of the tasks. Gathering requirements from the client is a task. That's why we call it as work task. Why the name given work task here? Gathering requirements from the client for development of a software system is a task. That is what work task. Then what is your work product? Based on the requirements, designing a software system which comes under work products, designing a software system. Next is what here? Milestones, to assess the progress of the project. That is what milestones. So achieving major milestones. Is it major milestones, minor milestones? Minor milestones means what here? Progress, is it some extent? Whereas major milestone is nothing but what here? The project was, major part of the project was completed. Milestone is nothing but what is the progress of the project? Is it major part of, means 70% of the project, is it completed, or 80% or 90% or only 40% completed? So milestones going to assess the progress of the project. Next is, once the project is completed, that's supposed to be delivered to whom? Your client. That is what deliverables we call it as, right? Next is what here? Quality assurance checkpoint. Quality assurance. What is the purpose of quality assurance? Quality assurance checkpoint. So giving assurance that the developed product is maintaining quality, giving assurance that the developed product is maintaining standards, ISO 9000 standards, Six Sigma standards. Is it? The so-and-so software industry which is developing a product based on the Six Sigma. Is it? The so-and-so software industry is developing a product based on the ISO 9000. That means to say quality assurance can be given about that particular product. Why? The product which is developed based on some standard. That is what quality assurance. Quality assurance checkpoints to improve the quality of the product, right? Checkpoints to improve the performance of the product, to improve the quality of the product, right? So this is what framework activities do. As usual, work tasks, work products, milestones and deliverables, quality assurance checkpoints, right? Similar way here, framework activities 3, right? Work tasks, work products, milestones and deliverables, quality assurance checkpoints, right? So this process framework which consists of 2 activities, framework activities and umbrella activities. Process framework which consists of 2 activities. What are those 2 activities? First one is of framework activities. framework activities, first one. Second one is of what here? Umbrella activities. First one is of framework activities. Second one is of umbrella activities. So what are the framework activities? To develop any software system, all these framework activities supposed to be conducted iteratively, right? So what are the various framework activities here? Communication is one of the framework activity. Communication is among one of the framework activity. So communication between whom here? Communication between client and developers. Was it? So once the client were communicating with the developers, so that developers can gather requirements for development of software system. That is what the importance of communication. Next one is of planning. So who has to plan here? Project manager, about the budget of the project, about schedule, about manpower, about resources. All this comes under planning. Next one is of modeling, right? So modeling is nothing but what here? Analysis, the gathered requirements, which consists of again analysis and design. Modeling, which consists of again analysis and design. The gathered requirements through communication. Is it requirements were gathered? Gathered requirements might have contradiction, ambiguity, incompleteness. Those supposed to be analyzed. After analysis, incomplete, contradictory, ambiguous requirements were discarded. Only useful requirements were specified in the form of document. Name of the document is what we call it as SRS document, software requirement specification document. Once the SRS document is ready, that's it. So what this SRS document consists of? Client requirements and project strategies, project plans. Once the SRS document is prepared, based on the SRS document, designers, they are going to design a software system. Means they are preparing blueprint, they are giving solution, right? Once they prepared the SRS document, the designers, they designed the software system. Once they designed the software system, they prepared blueprint, and later they prepared one document. Name of the document is SDS, Software Design Specification Document. Software Design Specification Document. Software Design Specification Document. Software Design Specification Document. SDS, right? So once the SDS document is ready, based on that, what here? Construction, which consists of code generation and testing. So based on this SDS document, programmers, they'll generate source code. Generated source code might have syntax error, semantic, logical processing error. To identify those errors, testing process. Testers, they'll perform testing process. Through testing process, all those errors will be identified, detected, and error report will be prepared. And the error report is given to again to the programmers. They'll perform debugging process. Debugging is nothing but correcting the errors. Now the application is error free. Once the application is error free, deployment will take place. Deployment represents what here? Delivering application to the client. That is what the importance of deployment, right? So those are framework activities, right? So to maintain the quality of the project, for any software project, umbrella activity is supposed to be conducted so that the developed product can maintain quality, right? What are the various umbrella activities here? Software project tracking and control. When the project is under progress, right, the software project is supposed to be tracked, supposed to be monitored. That's it. Tracking is nothing but what here? Supposed to be monitored. The software project, when the project is under progress, the software project is supposed to be monitored, right? And if the budget is not sufficient, schedule is what here? Lagging, slipped, right? Manpower is not sufficient. All those supposed to be adjusted. That is what we call it as control based on monitoring. That's it. If the schedule is lagging, budget is not sufficient, manpower is not sufficient. That's it. So all those supposed to be controlled. Supposed to be controlled is nothing but adjusted. That's it. All those supposed to be adjusted. That is what the importance of software project tracking and control. Software project tracking and control. Software project tracking and control. Next is of what here? One more umbrella activity is what here? Formal technical reviews. FTR. FTR stands for formal technical reviews. What is the importance of conducting these formal technical reviews? Who will conduct these formal technical reviews? Formal technical team will be there. Means FTR, formal technical review committee, which consists of software engineers, right? So software engineers, that's it. They'll conduct formal technical reviews. What is the purpose of that? To identify potential errors in the design of a software system or development of a software system at early stages, and those will be resolved so that development design cost will be reduced. That is what the purpose of conducting formal technical reviews. If formal technical reviews were conducted so that quality of the design of the product will be improved or increased, and development of the software system also improved. That is what the purpose of conducting formal technical reviews, right? So here FTR, let's take 5 members software engineers, right? 5 members software engineers. Is it FTR, formal technical review? Is it formal technical review meeting which consists of 5 members software engineers, right? Among them, one of the member is what will start the recording process, right? The designers, the review will be, formal technical review will be here. In this case, we are taking example here is on design model of a software system. When the designers, they had designed the model of a software system, right? So one of the designers going to give presentation to these 5 members. Is it among these 5 members, one of the member going to record the issues which were raised by other software engineers, which belongs to formal technical review, and they'll prepare one report. That report, design report, will be given to whom here? Designers, software designers. They will resolve those errors. Now the design model will become maintain quality and which can be designed based on the client expectation. That is what the importance of conducting formal technical review. The purpose is that, right? To improve the quality of the project. Next, coming to software quality assurance. What is the importance of software quality assurance? Giving assurance that the developed product is maintaining quality. How can you give assurance here? Because all work products, work tasks were conducted properly, software engineering activities, actions were conducted properly, then only we can give software quality assurance, right? That is one thing. And the developed product is maintaining standards. The developed product is developed based on the ISO 9000 standard, so that we can give quality assurance. The developed product is developed, is it, based on the Six Sigma standard. So we can say here quality assurance is achieved. That is what the importance of software quality assurance, is it? So software quality assurance can be achieved by conducting inspections, walkthroughs, reviews and all, so that quality of the product can be improved. That is what the importance of software quality assurance, right? Next is of reusability. What's the importance of this reusability? What is the importance of this reusability, right? We know what is meant by reusability, right? Reusability management. Software components were developed for one of the existing project, right? When the one new team is going to propose new project, and when they are developing the project, they can reuse the components from already existing project, so that the development time, development cost is less. That is what the purpose of reusability management, is it? Already existing project components can be used in newly proposed projects, so that the time will be reduced, even cost also will be reduced, is it? Those are the advantages with reusability management. That's the importance of reusability management, right? Coming to risk management. So what is the importance of risk management? We know what is meant by risk here. When the project is under progress, there were many types of risk might occur. Technical risks, business risk, is it? Economic risks, operational risks, market risk. There are various types of risks. Risk with respect to budget, risk with respect to schedule, risk with respect to manpower, is it, when the project is progress. All those risks supposed to be identified, is it, and supposed to be resolved. That process we call it as risk management. Once the risks were identified and managed, so that quality of the product can be maintained and that can be satisfied by the client. That is what the purpose of risk management, right? So all this comes under umbrella activities. So for development of any software system, right, any software project, right, all the framework activities should be conducted properly, as well as umbrella activities should be conducted properly, so that the developed product or project can maintain quality and which can be satisfied by the clients. That is what the importance of framework as well as umbrella activities, right? Next, we are going to discuss about software myths. First of all, what is myth? That we need to discuss in detail. What is myth? What does myth represent? That we'll discuss in detail. Software myths. Myth represent, right? So here erroneous belief. Myth represents what here? Software myths. Myth represents erroneous belief about software. Erroneous belief. Erroneous belief about software. Right? So what is software myths? Myths represents erroneous belief about software. Right? So myths, illusion, imagination. Illusion, imagination. Was it? So that is what myths. So in the mind of project managers, in the mind of software engineers, in the mind of client, is it? Some illusion, imagination, some erroneous conditions, is it? All these will occur which leads to project failure. That is what the problem with myths, software myths. What is the problem with software myths? What is the problem with software myths? Is it? All these stakeholders, they have wrong perception in their mind. Is it? Wrong belief, erroneous belief. Is it? Which can mislead to the project failure. So what are the various software myths? Software myths were classified into 3 categories. Software myths were classified into how many categories here? 3 categories, 3 types of software myths. What are those 3 types of software myths? One is of managerial myths. Managerial myths. Right? Another one is of practitioner myths. Practitioner myths. Another one is of customer myths. Another one is of customer myths. Another one is of customer myths. So 3 types of myths. 3 types of myths, software myths. Right? So first one is managerial myths, second one is practitioner myths, third one is of customer myths. Right? So what is here managerial myths? So managerial myths is nothing but manager is having, is it, misconception, misbelief, is it? Is it? So that is what we call it as managerial myths. Illusion, is it? Is it? Illusion, imagination in the mind. Manager is having illusion, imagination about the development of software system. Wrong belief about the software system which can lead to project failure. That is what managerial myths. Managerial means project manager. Practitioner myths means who is the practitioner for development of software system here? Who is the practitioner? So software engineers, we call them as practitioners. Software engineers. Software engineers, we call them as practitioners. Software engineers, we call them as practitioners, right? Software engineers, we call them as practitioners. So software engineers also having illusion, imagination, wrong condition, erroneous condition in their mind, which can lead to project failure. That is what the importance of myths, software myths. Coming to customer myths. So customers, end users or clients, even they also have their own illusion, imagination, wrong belief about the software project, right? Which leads to what here? Project failure. All these, what here? Myths, which leads to project failure. Was it? So these are 3 types of myths. About these 3 types of myths, we will discuss one by one. First myth is of managerial myths. Means illusion, imagination, is it? Wrong belief in the mind of whom here? Project manager or manager, right? What is that here? Book of standards is available. Book of standards is available. Book of standards is available. That is what the project manager is thinking, that some standard books were available in the library. That's it, the software industry library, right? So that my software engineering team can refer those books, standard books, they can develop the project in time, they can maintain quality. That is what the assumption in the mind of project manager. But coming to reality, how many software engineers are aware that the standard books were available in the library? How many software engineers will refer those standard books from the software industry library? Right? Right, is it? And if some of the software engineers, if they refer also, is the books having the content, is it best suitable for development of their project? All these are what here in reality, all these are no. That means to say false, is it? So if book available also, the content might not suitable for development of project. Some of the software engineers, they are not aware it. If some of them aware, if they refer also, content is not suitable for them. So this is what wrong belief in the mind of project manager, is it? Which can leads to project failure, that we call it as managerial myth. First managerial myth. What is the one more here? Project manager is thinking that if we get behind schedule, we can add more people. If we get behind schedule, we can add more people. That is what the illusion imagination in the mind of project manager, right? When the project is delayed, is it? If we add more software engineers so that they can complete the project within the given time, that is what the assumption or illusion in the mind of project manager. But this is not true. This is false. It's not possible. Is it? For the later project, if additional software engineers added, which will become more later, which makes more later. So that is what the problem with this particular myth, right? So let's take here example. Let's take for this. So 5-member software engineering team is working on the project. The duration which is given for them is 1 year. Is it? The project manager, the team, when the project is under progress, the software engineers team, they come to know that we cannot complete the project within the 1 year. That is the report which is given to project manager. Now project manager is thinking that if I add more 2 new software engineers so that I can complete the project, I can deliver the project within 1 year. But that's not true. That's not possible. Why? These new software engineers, from this again 2 members has to give. Existing 2 software engineers has to give training to these 2 new members, new software engineers. So how many people only work on the product here? Only 3 members. Is it? So here, what is the problem here? Existing software engineers also involved in the giving training to the new software engineers. That time, is it? Which takes more time. So which is again crossing 1 year. Even if you add more people also, is it? Later project will makes later because of adding 2 new people. So that is the problem here, which can lead to project failure. So that is what the illusion imagination in the mind of whom here? Project manager. That's a problem. Right? Coming to next myth. Outsource the project and relax. Outsource the project and relax. Let me take one example here. ACE Engineering College, which is given a project to whom here? IBM, right? Now IBM is not directly developing the project for ACE Engineering College, right? What the IBM is doing here is outsourcing the project to whom here? Google, right? But the IBM is not giving full details about this project to the Google. Is it? Google, with partial information only, they are trying for developing a software project for ACE Engineering College. They developed it and they again delivered to whom? IBM. IBM is delivered to ACE Engineering College. While evaluating it by the ACE Engineering College, the project is not based on their requirements. ACE Engineering College, what it will do? ACE Engineering College rejected the project because of IBM is given the development of this ACE Engineering project to third party Google. So Google not got proper requirements. Whose mistake here? IBM. IBM is not provided proper requirements, not understood proper requirements of ACE Engineering College, simply outsourced to third party software industry, which is not got proper requirements. Due to that, project is rejected, failed. So this is what the myth which was in the mind of project manager, which can lead to project failure, right? So this is the first category of myth. What is the second category of myth? Practitioner myths. So we already discussed to whom we call them as practitioners, Software engineers, we call them as practitioners. To whom we call them as practitioners here? Software engineers, we call them as practitioners, right? So these software engineers, they have illusion, imagination, erroneous condition, wrong condition in their mind. Is it? About the software project, right? So what is the first myth about the software engineer? Once we write the program, our job is done. Is it true? Once we write the program, our job is done. Is it true? Once the software engineers, they written the program, is it their job done? No. Once the program is written by the software engineers, that should goes under testing. Testers, they'll identify errors, again giving to whom here? Software engineers, developers or programmers, again they have to correct those errors. again reevaluated, again they have to correct. So once we write the program, our job is done, is the illusion, false condition, illusion, imagination, which can lead to project failure. That is one more myth belongs to software engineers. What is this next myth here? Next myth. Until I finish the program, I have no way of assessing quality. Second myth. What is second myth here? Until I finish the program, I have no way of assessing quality. Is it true? Until I finish the program, I have no way of assessing quality. In SDLC, is it? At each and every phase, quality can be assessed. Is it? By conducting inspections, by conducting reviews, by conducting formal technical reviews at various phases of SDLC, quality of that particular phase can be assessed. No need of waiting till completion of program source code generation. So this is also wrong illusion in the mind of software engineers, which can lead to project failure. That's a problem, right? So what is the next myth here? Software engineering makes us create unnecessary documentation. So the practitioners, they are thinking that software engineering makes us create unnecessary documentation. This is the wrong here. This is, in reality, this is wrong. Why? Software engineering will not allow you to create many documents. Only just 2 documents. Is it clear? What are those? SRS and SDS, that's it. Is it? So software engineering will not allow you to create unnecessary documentation. That's it. So that is the wrong illusion, imagination in the mind of software engineers, which can lead to project failure. Software engineering focus on how to conduct work tasks, work products, software engineering actions, activities, that's it, all those things. That's it. Software engineering not makes you to create unnecessary documentation. So this is what the illusion, imagination in the mind of software engineers, which can lead to project failure. Third category of myths were of customer myths. Customer myths. So even customers, clients or end users also having myths in their mind, right? So what are those customer myths that we'll see here, right? How the customers they are thinking, right? So first myth of customer is a general statement of requirements is sufficient. A general statement of requirements is sufficient. A general statement of requirements is sufficient. So customers think that if I give general statement of requirements to development team, with that they can develop a project, they can deliver the project. Is it true? Is it general statement mean partial requirements for the development of software system? Is it enough? No. In detailed requirements is required for development of software system. This is the false assumption in the mind of customer, which can lead to project failure. That's why we call it as customer myth. That's why we call it as what? Customer myth. What is the next myth here? What is the next myth? The next myth which we are going to discuss is of software requirement changes. Software requirement changes can be accommodated as software is flexible. Is it possible? Software requirement changes can be accommodated as software is flexible. Software requirement changes. Is it possible to accommodate the changes, frequently given changes by the client? What is the problem with that? When the clients were giving frequent changes, is it frequent changes, accommodating those changes, the development cost, the design cost, development cost is increasing, even time also increasing. That's the problem. Is it clear? So these are all the myths, 3 types of myths, right? Next we are going to discuss about software development life cycle models. Software development life cycle models. What are the various software development life cycle models that we'll discuss here? Software development life cycle models, what is the purpose, what is the need, that we'll discuss briefly, right? Software development life cycle model. A software life cycle model, also called as process model, is a descriptive and diagrammatic representation of the software life cycle. Descriptive and diagrammatic representation of the what here? Software life cycle, right? A life cycle model represents all the activities required to make a software product transit through its life cycle phases. What is the need for this software life cycle model? What is the purpose? Life cycle model is also called as what here? Process model. What is the need of process models? That's it. So any software engineering team, if they want to develop a software system, they have to select the best suitable process model for development of software system, right? And without using up any particular life cycle model, what will happen here? The development of a software product would not be in a systematic and disciplined way. If the software engineering team, if they want to develop a new project, if they have not selected, if they won't select any process model, what will happen? They cannot develop a project in a systematic way and disciplined way. Once the project is not developed in a systematic way and disciplined way, which can be rejected by the client, there is a huge loss to the organization. That's why any software engineering team, if they want to develop a project, they have to select best suitable process model for development of their project. That is what the importance of process models, right? When software product is being developed by a team, there must be clear understanding among the team members. So when the software team is going to develop a project, all the team members should have clear understanding about the project. What is the problem? What is the requirements which is given by the client? What are the client expectations? All the team members should understand. Then only they can develop a proper project. Otherwise, which can lead to what here? Project failure. Is it? All the team members, if they don't have clarity about what exactly the project, what are the client requirements? What are the client expectations? That's it. If there is no clarity among the team members, what will happen? Which can lead to project failure. Once the project is failed, there is a huge loss to the organization. That's why software engineering team has to select best suitable model for development of any software system. Right? So we are going to discuss about here process models. Process models were majorly classified into three categories. Process models were classified into three categories. Process models are of three categories. First one is prescriptive process model. Prescriptive process model. Prescriptive process model. First one. Second one is of evolutionary process model. Evolutionary process model. Third one is of agile process model. Agile process model. Process model. So process models were classified into three categories. First one is of prescriptive process model. Second one is of evolutionary process model. Third one is of what here? Agile process model. Third one is of what here? Agile process model. So what is the importance of this prescriptive process model? In this prescriptive process model, all the process elements were prescribed. What are those process elements? All the framework activities, that is communication, planning, modeling, construction and deployment, and all the umbrella activities were prescribed. That's why the name given prescriptive process models. In the prescriptive process models, process elements were prescribed. Means to say, what are those process elements? Framework activities as well as umbrella activities were what here? Prescribed. That's why the name given here, prescriptive process models. Right? Next one is of evolutionary process models. What is the importance of this evolutionary process models? What is mean by here evolutionary? What is the need here? When the clients were giving very frequently changed requirements, those frequently changed requirements supposed to be accommodated. So that accommodation of frequently changed requirements can be done by using these evolutionary process models, right? So those evolutionary process models can work still some extent, but having some its own drawback. That's why agile process models were introduced. Right? In evolutionary process models, the client was given the requirements when the project is almost at the end. It's very difficult to accommodate those changes, newly introduced changes. If they try the development cost, schedule, manpower will increase. There is a huge loss to the organization. That is what the problem with evaluation process model. That's why agile process models were introduced. Agile process model is also called as one of the modern software process models. Nowadays, almost all the software industries, they are using agile process model. Nowadays, almost all the software industries which are using agile process models means one of the modern software process models. So agility, frequent changes, client requirements, which were clients were giving frequently changed requirements when the project, whatever stage it might be. It might be in design stage or development stage or almost at validation phase. Even then also, client is giving frequent changed requirements. Those supposed to be accommodated within the budget, within the schedule, with the given manpower. That is possible by this agile software process model. That's why agile software process models became popular. That's why agile software process models became popular. That we'll discuss, right? Let's see. One of the prescriptive process model. These are all prescriptive process models. Prescriptive process model. One of the prescriptive process model is waterfall model. What is the importance of this waterfall model? Waterfall model is a collection of framework activities. Waterfall model is a collection of framework activities. Why the name given waterfall model? Here framework activities were conducted in the form of flow of water. That's why the name given waterfall model. Waterfall model is a linear sequential process model. Linear sequential process model. Waterfall model is a linear sequential process model. In waterfall model, all the framework activities were conducted in a linear sequential manner. That's why the name given here, waterfall model. Another name for waterfall model here is classic life cycle model, also called as classic life cycle model. Classic life cycle model. Linear sequential model are also called as classic life cycle model. So this waterfall model is a collection of what here? Framework activities. What is that here? Communication is one of the framework activity. Planning, modeling, construction, deployment. Right? All these framework activities were conducted in a linear sequential manner. So initially communication will take place. Project initiation for development of software project. So requirements gathering. Who will provide requirements here? Client will provide requirements to the development team. So development team, they communicated with the client, they gathered the requirements, right? Then planning. Project managers, they'll plan about the project, estimating, scheduling, tracking. So planning about budget, schedule, manpower, resources and all, right? Once the planning is done, modeling will take place here. Modeling consists of analysis and design. The requirements which were gathered might have contradiction, might have ambiguities, might have incompleteness. That's why analysis should take place. All those contradictory, incomplete, ambiguous requirements should be discarded through analysis process. After analysis, what will be prepared here? SRS document will be prepared, software requirement specification document. Based on this, what will take place here? Design will take place. Designers, they'll give blueprint, and once the design is done, designers, they'll prepare STS. Based on this STS, what will take place? Construction. So construction consists of code and testing. So programmers, they'll generate source code which have some errors, syntax errors, semantic processing, logical errors. Testers, they'll perform testing process, they'll identify those errors, they'll prepare error report that is again given to whom here? Programmers. They'll perform debugging process. Now the application is error free. Once the application is error free, error free application can be deployed. Deployment, delivering error free application to whom here? Client. Now client, they'll evaluate and they'll give feedback. If they identified any minor changes, those minor changes supposed to be whom here? Again communicated with whom here? Again communicated with the development team. Client, and client development team, they take the feedback of client and they'll improve again. They'll again communicate with the client, development team, and they'll gather the changed requirements. Again planning will be changed. Again improved modeling. Again improved construction, again redeployment will take place. Again client will evaluate. This process will continue. Linear sequential manner. So for example, in the waterfall model, once the software engineering team is modeling a software system. Here, there is a problem with planning. So from modeling to planning cannot be go back. This is not possible. This is the drawback. This is the major drawback with waterfall model. We cannot move to previous phase. When the team is already modeling, if some changes given by the client at planning phase, the team cannot go back and do changes in this planning phase. They have to move forward. This is the problem with waterfall model. And what is the other drawbacks with waterfall model? Because the software project development is in a linear sequential manner, the time required for development of the software system, software application project is more. That is one more time consuming. That is one more problem with waterfall model. So what are there are few advantages also there with this. Easy to understand, easy to use. Advantage of waterfall model is what here? Easy to understand, easy to use, right? And works well when quality is more important than cost or schedule. Works well when quality is more important than cost or schedule, right? What are the drawbacks or disadvantages of waterfall model? What are the drawbacks or disadvantages of waterfall model? What are the drawbacks? That we'll see here. Drawback of waterfall model is difficult to find customers to state all requirements explicitly. So in waterfall model, client has to provide all the requirements at early stage before going to develop a software system. That's very difficult for the clients or customers, right? They cannot provide all the requirements, is it, at initial stage of development of software system. That is the major drawback with waterfall model, right? Difficult to find customers to state all requirements explicitly before going to begin the software project development using waterfall model. That's a drawback. Customers must have patience. Why customers must have patience here? Is it delivering final version of the software project by using waterfall model, which takes more time. That's why customers must have patience to wait to get the final version of the software project. Why? Waterfall model is a linear sequential process model which takes more time to develop a software product or software project, and developing and delivering, which takes more time. That's why customers must have patience. These are the drawback of waterfall model. These are the drawbacks of waterfall model. So this is one of the prescriptive process model. What is the one more prescriptive process model? Incremental process model is one more prescriptive process model. Incremental process model is one more prescriptive process model. Incremental process model is one more prescriptive process model. So about this incremental process model, we'll discuss in detail here, right? Let's see here. Software. So x-axis represents here project calendar time, whereas y-axis represents here software functionality and features. Software functionality and features. Software functionality and features, right? Incremental process model. In this incremental process model, right, all the framework activities were conducted here. So in increment 1, so here communication, planning, modeling, construction, deployment. So right, so in incremental process model, first increment of software system can be built with few requirements. Is it with few client requirements? First increment of software system was built, and delivery of first increment. Delivery of first increment to whom here? Client, right? Client was evaluated the first increment of software system, and they identified, is it, some of the features were not available, lack of features, some requirements. They changed requirements which is given by them in the first increment. With those changed requirements, the development team, they developed the improved version of increment 2 of software system, improved version. What are the changes which is given by the client while evaluating the increment 1? With those changes, development team has developed increment 2. Simply I can say here, this is version 1. Version 1 was developed, delivered to the client, client evaluated, they identified some more additional features, functionalities we need. With those changed requirements, is it, the development team is developed version 2, right? Improved version of software system. They conducted communication, planning, modeling, construction, deployment. They delivered the second version 2, right? Again, version 2 also delivered to the client, client evaluated version 2. Again, they identified some more additional features, some more functionalities, some more advanced requirements and all. With those changes, again, the development team, they want to develop here increment 3. That is what here? Version 3, improved version 3. Again, version 3 was evaluated by client. As it, client, they evaluated version 3 and they are expecting more advanced features. With those changes, development team, as it, they are developing increment 4 version, and they had delivered version 4. Again, version 4 also evaluated by whom here? Client. Once the client evaluated the version 4, they come to know that the version 4 is having almost all the features, functionalities, and which is based on their expectations. They satisfied with version 4. The development team, they considered version 4 is the final version of the software system, final version, which is having almost all the features which was satisfied by the client. So this way, incremental process model helps to develop quality product. That is what the importance of incremental process model. That's the importance of incremental process model. Let's see one more example here. So, word processor software, word processing software. One example we are taking here, one example of incremental process model, word processing software, which was developed by word processing software, which was developed by using which process model here? Incremental process model, incremental process model, right? Incremental process model, right? So in the first increment, what they developed? Basic file management, editing, and document production, Whereas in second increment of software, what they developed? More sophisticated editing, right? And document production. Was done here, right? Whereas in third increment, what is taken here? So the feature which was added here is spelling and grammar checking. Features were added to the product, right? Whereas in fourth increment, advanced page layout, feature was added. Now observe carefully here. In the first increment release of software, basic file management, editing, and document production. Whereas in second increment, more sophisticated editing, document production. Whereas in third increment, spelling and grammar checking. Whereas in fourth increment, advanced page layout. So which version is having almost all the features which were satisfied by the client? Fourth increment. Why fourth increment of software release of software? That's it. Which is having basic file management in it, editing, document production, more sophisticated editing, document production, spelling and grammar checking, and advanced page layout also. So when the fourth increment of version of software system is evaluated by the client will satisfy. Why? Fourth version having almost all the features which were satisfied by the client, which was developed based on their expectation, based on their needs. The clients were satisfied. Fourth increment version of the software system consider release, fourth increment release of the software, which is considered as final version of the software system. So this way, incremental process model helps to the development team as well as client to develop more quality software product. So that is what the purpose of incremental process model. Right? So what are the advantages with this incremental process model? That we'll see. What are the advantages with incremental process model? This model is used when staffing is unavailable. So what is the purpose? When the so-and-so software industry, let's take XYZ software industry, XYZ. They have very less number of staffs. Even then also they want to develop a software project. In that case, they can choose this incremental process model. How? That we'll see. So at version 1, at first increment, with few software engineers, they can develop the version 1. That's it. Coming to it, increment 2, they can add more additional software engineers. So that's possible. So initially with few software engineers, they can start development of project. So in that situation only, incremental software process model is best suitable for development of software system. This model is used when staffing is unavailable initially, right? Later they can add, right? Generates working software quickly and early during the software life cycle. During the software life cycle, generates working software quickly and early during the software life cycle, right? Next, one more prescriptive process model which we are going to discuss is of rapid application development model. RAD stands for rapid application development. So RAD stands for rapid application development. So what is the importance of this RAD, right? So rapid application development means quickly development of software system, very quickly. That's it. So RAD model going to develop the software application very quickly. That's why the name given rapid application development, right? Let's take here software application, large complex software application, which gets divided into modules, what? Modules. Module 1, right? Again what here? Module 2. Again next what? Module 3. Module 1, Module 2, Module 3. And next what? Module 4. Right? So large complex software application gets divided into modules. Module 1, Module 2, Module 3, Module 4, right? So now the multiple RAD teams, they can work parallelly on these modules. Let's see here. So RAD model, which consists of framework activities, communication, planning, RAD team 1, RAD team 2, and so on, RAD team n. That is modeling, construction. Both can be performed parallelly. And all these RAD teams, modeling, construction, which were performed parallelly, which is going to be integrated and producing deployment, delivering a product to the client, right? Now let's see here. So modeling, modules, right? So modeling and construction. So here for this year, RAD team 1 is working. RAD team 1. Let's take here. RAD team 1, right? RAD team 2, RAD team 3, RAD team 4, right? So these teams working parallelly. RAD team 1 working on modeling, RAD team 2 modeling and construction, RAD team 3. So all these modules were developed parallelly. What is the advantage with this? The time required for modeling and construction of software system is very rapidly, within 60 to 90 days. Within 60 to 90 days, the project can be developed. That is what the advantage with RAD model, rapid application development. Why? Modeling and construction phases, which can be developed by multiple RAD teams simultaneously, so that the time required for modeling and construction of a software system is very less. That's why they can deliver the product very quickly. That is what the advantage with rapid application development, right? Communication between client and development team, So that is once the clients were communicating with the client, so that once the clients were communicating with the development team, so that development team can gather the requirements, planning can be done by the project manager, right? Then here modeling means here building software system. So modeling is nothing but what here? Modeling is nothing but preparing blueprint for the software system. Modeling is nothing but preparing blueprint for the software system. Once the blueprint is prepared, based on that, construction will take place, source code generation. Again, here RAD team 2 also. So here, modules were, multiple modules were developed by multiple RAD teams parallelly, so that the time required for modeling and construction is very less, and all the modules will be integrated and form a single application here. What is that single application here? That software application, integrated. That is what the integrated software application would be deployed to whom here? Client. integrated software application, which was integrated software application, which was deployed to whom here? Client. So this is what the importance of RAD model, right? So what are the drawbacks of this RAD model, rapid application development? What are the drawbacks of this RAD model? That we'll discuss. What are the drawbacks of RAD model? RAD model. Drawbacks of RAD model, rapid application development. Drawbacks of RAD model, rapid application development. So for large projects, sufficient human resources are required to create RAD teams. So here, if any software engineering team, if they want to use RAD model, they need more RAD teams. Why? For large projects, sufficient human resources are required to create RAD teams. So if any software industry, if they want to use RAD model for development of their software system, they need more human resources. That is one of the drawback of RAD model. What is the next drawback here? Next drawback is developers and customers must be committed. It's not possible. So continuous communication between developers and customer is difficult in RAD model, right? That is one more drawback. What is the next drawback? If system cannot be modularized, then RAD will be ineffective. So without modularizing, just know VISA, right? What is that? Software application, suppose gets divided into modules. Then individual modules will be given to individual RAD teams. RAD team 1, RAD team 2, right? RAD team 3, RAD team 4. So multiple RAD teams, they are working on multiple modules, multiple RAD teams, they are working on multiple modules, right? So if the large complex software application, if it is not gets divided into modules, then RAD model is not suitable here. So here, if system cannot be modularized, RAD will be ineffective, right? And there is one more drawback. If high performance is an issue, then RAD approach might not work. If high performance is an issue, right, then rapid application development, RAD approach might not work. So these are the drawbacks of RAD model. One more drawback is RAD might not be appropriate when technical risks are high. When technical risks are high in the application, then RAD approach might not be appropriate. So these are the drawbacks of RAD model. Right? Next we are going to discuss evaluationary process model. So far we had discussed prescriptive process models. What are those? Waterfall model, incremental process model, and RAD model. Those are 3 prescriptive process models. Next we are going to discuss evaluationary process models. Evaluationary process models. First one is of what here? The prototype model. So what is the importance of prototype model? So prototype represents what here? Building initial version of a software system or building sample model of a software system, which is evaluated by the client, later which can be improved. That is what the importance of prototype model. The purpose is that, right? Now observe carefully this prototype model, which consists of framework activities, communication, quick plan, modeling, that is quick design, construction of prototype, deployment, delivery and feedback. Right? Now observe carefully here. In the prototype model, communication between client and development team will take place. Clients will give requirements to the development team. With those requirements here, quick planning can be done by the project managers. Once quick planning is done, modeling can be done, quick designing, preparing blueprint for the software system. Based on the design, construction of prototype will take place. Initial version of a software system, initial version or sample model of a software system. Once initial version or construction of prototype is nothing but what here? Construction of prototype means building initial version of a software system, initial version or sample model of a software system, sample model of a software system, right? So once initial version of a software system, so initially with few requirements in first iteration. So prototype, this evolutionary process model is an iterative process model. Is an which process model? Iterative process model. Iterative process model. Evolutionary process model is an iterative process model, right? In the first iteration, with few requirements, the client is given with some few requirements, few client requirements, with few client objectives, not detailed client objectives, few requirements, was it? And with the few requirements, was it? With few requirements, the first first version of the software system was started development by the development team, and design modeling is done. Was it clear? And quick design, and here sample initial version of software system was developed, and which is delivered to whom? Here, client. Now client, they had evaluated here, and they come to know that the first initial version of the software system, was it, which is having lack of features in it, was it, lack of requirements, was it, they evaluated and they given the feedback. With that feedback, the development team, they are trying for constructing the next version, improved version of the prototype, right? Improved version, that is second iteration. With the second iteration, improved version, is it? That is simply I can say here improved version, improved version of prototype. Again, this is delivered to whom? Here, client. Client again evaluated, they come to know that some more additional features, functionalities required for them. With those changes, again development team, they started third iteration, and they developed here, is it more improved version? That means to say here version 3. Again, this version 3 was evaluated by the client. They come to know that we need more advanced features. With those changes, again development team, they had started fourth iteration of development of improved version of software system, and they developed here version 4 prototype, version 3 prototype, version 4 prototype. Again, which is evaluated by the client, was it? Again, which is evaluated by the client. At this stage, client come to know that the version 4 prototype was almost built based on our needs, our expectations, and which is satisfied by us. That is what the feedback is given by the client. With this, they will stop the process, and the development team considered version 4 prototype is the final version of the software, which was having almost all the features, functionalities, and which was satisfied by the clients. This way, this prototype model helps to whom here? Client as well as developers. Client as well as developers, right? Client as well as developers. So initially, the clients, they given few requirements, is it? So prototype model allows to the client and developers to better understand the requirements. In the initial version, is it? In the initial version of software system, when developers also not aware, is it? What is the algorithm which they had used? Might be inefficient algorithm, and the operating system which they might be selected, is it? Might not be what here? Might not be best suitable, and the programming environment which is chosen by the developer might not be appropriate, right? So those are all the what here problems with the developers. So in first version, is it? When the first version was evaluated, they can improve. So developers also can understand what is the best suitable algorithm, what is the best suitable operating system, what is the best programming language. Even clients also can give more detailed requirements. So in prototype model, both clients as well as developers, they can better understand the requirements of the software system, so that at the end they can develop the quality software product which can be satisfied by the clients. That way, prototype model helps to the client and developers to better understand the requirements of the software system, so that they can develop better quality software product. That is what the purpose of prototype model, right? What's the disadvantages with the prototype model? What is the disadvantages with prototype model? What is the disadvantage with the prototype model? Let's see here. Customers is what appears to be the working version of the program. So in prototype model, the development team has developed the initial version, sample model of a software system. By seeing the initial version, sample model of a software system, customers thinks that this is the final version. But that is what one of the drawback. Why? Initial version don't have additional features, functionalities, all the features and all. That is one of the drawback of prototype model. What is the next drawback here? Developer makes implementation compromises with this prototype model. Just now we had discussed, right? So whatever operating system available, what are the implementation language available, what is the algorithm available, directly the developers they can use it, and they'll develop the first increment of prototype, second increment, third increment, and later is it, and they'll simply deliver to the client, right? Later is it, the algorithm which might be inefficient, the operating system which they used might not be suitable, programming environment might not be better usable in the environment, is it? So later, which was what here come to know. So that means to say developer makes implementation compromises. What is available directly the developer will use in the various development of prototypes, prototype version 1, version 2, version 3. Is it? They won't think, oh, is the algorithm efficient or not? Is the operating system best suitable or not? Is the programming environment, is it suitable or not? All those they won't think. That is one more drawback of prototype model. That is one more drawback of prototype model, right? Coming to spiral model. So one more evolutionary process model is of which model here? Spiral model. One more evolutionary process model. One more evolutionary process model is of spiral model. So what is the importance of the spiral model? That we'll discuss. So the spiral model is a combination of, spiral model is a combination of spiral model is a combination of iterative prototype model plus linear sequential model. That means to say which model? Waterfall model, right? So spiral model is a combination of two models. What is that? Iterative prototype model and waterfall model, right? So what's the importance of this spiral model? In spiral model, all the framework activities were framed in the form of spiral, right? Communication is one of the framework activity, right? And planning one more framework activity, modeling one more framework activity, construction one more framework activity, deployment one more framework activity, right? So all the spirals. So here at initial spiral with core product, see here core product will be built in initial spiral, core which will start from here, core product will be built means with few requirements, was it? Which will be built, and the core product will be evaluated, and what is the risk involved in that core product that will be evaluated by the client, and those risks were identified and tried for improving, resolving in the second spiral. Again, second spiral, improved spiral was developed, again evaluated here, and risks were identified, and those were trying for resolving in the third spiral. Again, in third spiral, some additional feature functionalities were identified, some risks were identified, those were improved and resolved in the fourth spiral. And that is again evaluated by the client, as it, and the client they satisfied at fourth spiral, which is the complete version of the software system, which was developed based on the client needs, client expectations. So this way, the spiral model going to help to the client, as it, to resolve the risk at each and every spiral. So spiral model is a risk-driven software process model. There is no other model going to solve the risk, going to identify the risk. Only spiral model which can identify risk, and those risks were resolved at various spirals. That is what the importance of spiral model. So spiral model which consists of what here framework activities, communication between client and development team with few requirements. First spiral will take place. Planning, estimation, scheduling, and risk analysis, right? Modeling, analysis and design. So SRS document, STS design, construction, code and source code generation and testing will be performed, and deployment, delivery and feedback. So with few requirements, first spiral will take place here, and risk analysis will take place. This is what the spiral model going to identify risk at each and every spiral. Those identified risks will be resolved in the next spiral, right? And is it this way, each and every spiral going to improve, and the final spiral will give what here? Improved complete version of the software's application, which was satisfied by the client, which can maintain quality. That is the purpose, right? Now the point here is the risk identification, risk resolution can be done by whom here? So spiral model is a combination of iterative prototype model as well as linear sequential model. So iterative prototype model going to resolve the risk in each and every spiral. Iterative spiral model, iterative prototype model going to give the resolution for the identified risk. Iterative prototype model going to give the resolution for the identified spiral. Going to give the iterative prototype model going to give the resolution for the identified risks, right? So this is about spiral model. What are the drawbacks of spiral model? Spiral model is having its own drawbacks. What are those drawbacks? That we'll see here. What are the drawbacks of spiral model? Let's see. There are some drawbacks of spiral model. What are those drawbacks is of? Let's see. It is difficult to convince customers. First drawback of spiral model is it is difficult to convince customers. It is very difficult to convince customers, right? That is the first drawback of spiral model. What is the second drawback here? Risk assessment expertise is required. Some experts required to identify the risk, analyze the risk, and give resolution for the risk. So that is second drawback of spiral model. What is the third drawback of spiral model? If major risk is left uncovered, the problems might occur, is it? Some of the risks were identified at each and every spiral, but those risks were not given resolution. That will become what here? If the risk is left uncovered, there is a huge problem, big problem. So these are the drawbacks of spiral model, right? Next, we are going to discuss about the unified process. So what is the importance of this unified process? What is the importance of this unified process? That we'll discuss briefly here. So in some ways, the unified process model, unified process model is an attempt to draw on the best features and characteristics of traditional software process models. What are the traditional? Traditional is nothing but what here? Old software process models. So waterfall model, incremental process model, RAD model, these are all the old software process models. So this unified process model going to get the best features from those process models, while developing a software system. So unified process model going to get the best features from the old software process models, and characteristics from those software process models, but characterize them in a way that implements any of the best principles of agile software development. About this as well we'll discuss in coming topic, right? So the unified process recognizes the importance of customer communication. So unified process model recognizes what the importance of customer communication. Without customer communication, development team cannot get the complete requirements for development of software system. That's why unified process model recognizes what here? Important thing is customer communication plays major role to get the proper requirements from them. And streamlined methods for describing the customer's view of a system, right? It emphasizes the important role of software architecture. This is software architecture. What is software architecture? Any software architecture is a collection of components and interfaces among components can form software architecture. Collection of components and interfaces among components can form software architecture, and helps the architect focus on the right goals. Right? Such as here understandability, better understandability of architecture, right? And reliance to future changes, some changes which was suggested by the client, those changes supposed to be accommodated, and reuse, right? About this unified process model. Unified process model which consists of various phases. What are those phases here is? Unified process model. Unified process model phases, which consists of, first one is of inception phase, right? Second one is of elaboration phase. Third one is of construction phase. Fourth one is of transition phase. Right? So unified process model phases, which consists of inception phase, right? Elaboration phase, construction phase, and transition phase, right? So now observe carefully here. inception phase of unified process model, which which includes, is it two framework activities. What are those here? Communication and planning. Communication and planning. In communication, what will take place here? In communication phase, gathering requirements from the client and preparing a rough architecture, that will take place here. Gathering requirements, right? Gathering requirements, right? And rough architecture can be built. Rough architecture can be built, right? So in inception phase here, gathering of requirements from client and rough architecture can be built, right? So that is what the importance of what here? Inception phase, right? And here, as well as here, use case scenarios can be built here, use case scenarios, right? And whereas in elaboration phase which includes two framework activities, planning and modeling. In this elaboration phase, what will take place here? Elaborating the elaborated requirements model. Elaborated requirements model can be built under this elaboration phase. Elaborated, so detailed requirements model can be constructed here, and as well as detailed architecture of the software system can be built at this elaboration phase. Detailed architecture of the software system, design model of the software system, right? And modeling is done. Based on that modeling here, construction, source code generation will be done here. Once source code is generated, testing will be applied here. Errors were identified and error report was prepared by the testers, that is given to development team. They will correct those errors. Now the application is error free. So transition will take place here. Transition phase, which includes here construction phase and deployment phase. Once the source code is error free and that is delivered, deployment is delivered, the error free application to the client, they will evaluate and they will release what here? First version, software increment 1, simply you can say here, software increment 1, and that is evaluated by the client. If they identified any changes, those changes will be given to whom here? Development team. With those changes, development team will develop here second iterative release of the software application, improved version. Again, that is delivered to whom here? Client. Again, which was evaluated by the client. Is it? Again, the client is given some more additional features, functionality. With those changes, again the development team, they had developed third what here? Release of software, improved version. Again, that is evaluated by the client. If they identified some more additional features, functions we need, with those changes, development team, they developed the fourth release of software. Again, that is evaluated by the client. The client satisfied with the fourth release of software, they'll stop the process, and that is considered as final version of the software system, right? So here production, that means to say here providing all the details, operating installation details, operating procedures and all, right? So this is about unified process model, right? So here elaboration defines and expands the preliminary use cases. We know what is meant by use case. Is it? Use case, set of sequences of operations which is performed by a software system. We call it as use case, right? So who will interact with this use case here? Actors. We call them as actors, or we call them as users, right? So is it users, right? So, right. Let's take here ATM application, right? Here is the ATM user, is it? And here is the ATM application. Let's take ATM application. This is system boundary. This line represents what here? System boundary. So user can perform what operations here? Withdraw, right? Deposit, right? Check balance, right? Check balance, right? So this is what we call it as elaboration defines and expands the preliminary use cases, means giving requirements of the software system. That is what the purpose of building preliminary use cases that were developed as part of the inception phase and expands the architectural representation. So architecture, so any architecture is a collection of components and interfaces among components to include 5 different views of the system. So system can be viewed in different views. What are those different views? Use case model. This is what the best example for use case model. So any use case model is a collection of use cases, and is it set of use cases, set of actors. That's it. So communication among use cases and actors, use case model, right? Which can represents the use case model purpose here is to represent the functional requirements of a software system, so that the development team can better understand. So what are the requirements required for the client? Using use case model, the development team, they can better understand the functional requirements of a software system. what functionality the user is expecting from the ATM application or the software system. That can be viewed through use case model. That is what the importance of use case model. Through use case model, the development team, they can better understand the what exactly the user is expecting the functionality or features from the developed software application. That is what the purpose of use case model. Requirements model. We know the requirements model. So client requirements can be specified here. So client once given the requirements, right? So are those requirements, is the client given complete requirements, proper requirements or not? Through this requirements model, this the development team, they can better understand the requirements of the client. Through design model. So through design model, the design software system, the design model means the preparing blueprint by the designers. Is the designed blueprint, is it designed based on the client expectation, client needs or not? Through design model, the designers, they can better understand the design model of a software system. Implementation model. Through implementation model, is source code generated based on the design model or not? That can be viewed by the developers, right? Deployment model. Through deployment model, is the project which was deployed to the client, is it based on their needs, expectations or not? Is the project which was deployed in the system, is it properly deployed? Is it executing properly or not? What is the result? What is the output? Is the expected output and actual output, if both were matching, then the deployment model, through deployment model, they can view it, right? So if it is not matching, means there is a mismatch. Means the project supposed to send under maintenance phase, supposed to be resolved, right? Next, we are going to discuss agile development. Next, we are going to discuss about what here? Agile development. So what is the importance of agile development? That we'll discuss. What is the importance of agile development? Agility. So clients always give frequent changed requirements. When the project is under progress, that might be in design phase or implementation phase. At that particular phase also, the client is giving change requirements. Those change requirements supposed to be accommodated within the budget, within the cost, within the budget, within the schedule, with the given manpower only. So that is possible by this agile software process model. So one of the modern software process model, agile development. Agility. Everyone is agile, and agile team is a nimble team able to appropriately respond to changes. Who will give more frequent change requirements here? Clients. Frequently changed requirements, whatever frequently changed requirements is given by the client at any stage of project development, that's supposed to be accommodated within the budget, within the schedule. That is possible by agile software process model. That's why agile software process model is one of the modern software process model. Nowadays, almost all the software industries, they are using agile software process model. That's it, because of changed requirements can be easily accommodated within the budget, within the schedule. That's why agile software process model became popular. Change is what software development is very much about, right? Changes in the software being built, changes to the team members, changes because of new technology, changes of all kinds that may have an impact on the product they build or the project that creates the product. So whatever changes which is given by the client, or there is a change in the team, software engineering team, there is a change in the client requirements, there is a change in the technology, all those supposed to be accommodated properly. That is possible by this agile software process model. Right? An agile team recognizes that software is developed by individuals working in the teams, and that the skills of these people, their ability to collaborate is at the core for the success of the project. Right? Agility and the cost of change. So, if any software engineering team, if they develop a software project by using traditional old software process model, and if the frequent changes was given by the client, what is the cost? What is the schedule? If the same project frequently changed requirements which is given by the client, if the software engineering team is selected the agile software process model, frequently changed requirements accommodated, what is the cost, what is the schedule? That which we are going to observe here, agility and the cost of change. The conventional wisdom in software development is that the cost of change increases non-linearly as a project progresses by using traditional old software process model. It is relatively easy to accommodate change when a software team is gathering requirements early in a project. But proponents of agility argue that well-designed agile process flattens the cost of change curve, allowing a software team to accommodate changes late in a software project without dramatic cost and time impact. Now the thing here is, by using traditional software process model, Next is agile software. Agile software process model, also called as modern software process model. Modern software process model. Modern software process model. Now observe the point here. Traditional software process model, agile software process model, or modern software process model. Observe here. When the software engineering team is developing a software project using this traditional software process model, old software process, waterfall, incremental, RAD, prototype, spiral and all, right? So the software engineering team is almost at implementation phase. The client is given major change. So those major changes supposed to be changed to design, is it even requirements and all. So accommodating all those major changes by using traditional software process model, the cost is high, cost and schedule is too high to accommodate all those major changes, is too high. That is the problem with this particular traditional software process model. What is the solution for this? If the software engineering team, if they use agile software process model, now the team is almost at implementation phase, the client is given major change requirements, so design supposed to be changed, requirements, planning, all those supposed to be changed, right? Even then also, because they are using agile software process model, within budget and schedule, right? Whatever changes which is given by the client can be done within the budget, within the schedule. So that's why this agile software process model, modern software process model became popular. Now we'll see this one with the help of diagrammatic representation. Change costs as a function of time in development, right? Now observe carefully. X-axis represent development schedule progress, development schedule progress, right? And y-axis represents development cost. Let's take the software engineering team. They had developed a software project by using which software process models here? Conventional software process models, or old software process model, or traditional software process model, or traditional software process model. They had used conventional software process model or old software process model, what is the cost here? That which we need to observe. The team, they had selected old software, conventional software process model or old software process model, to accommodate the major changes which is given by the client. The cost is too high. The cost is what here? Time also high, cost also high, right? Whereas the software engineering team, if they use agile software process model or one of the modern software process model, accommodating changes, client frequently changed requirements, accommodating, here the time also less as well as cost also less. That's why here idealized cost of change using agile process model almost very less if they do some simplifications, which is very less. So accommodating frequently changed requirements by the client in the project by using agile software process model is very cost as well as schedule is very less. That's why this agile software process model became popular. That's why nowadays almost all the software industries which they are using agile software process model for development of software system. Agile software process model for development of software system, right? Next we are going to discuss extreme programming. Next we are going to discuss extreme programming. So what is the importance of this extreme programming? What is the importance of this extreme programming? About the extreme programming which we are going to discuss in detail. About this extreme programming which we are going to discuss in detail, right? Extreme programming. Extreme programming, the most widely used approach to agile software development. Extreme programming, right? The most widely used approach to agile software development, right? So extreme programming was most widely used, very frequently used by whom here? Agile software process model. Agile software process model. Extreme programming, which was more widely used by the agile software process model. So what is the purpose of this extreme programming? How extreme programming helps to the agile software process model to develop efficient quality software product? That we'll see about extreme programming, right? More recently, a variant of extreme programming is called industrial extreme programming has been proposed, means improved version, is it? So, industrial extreme programming refines extreme programming and targets the agile process specifically for use within large organizations. So, large organizations, if they want to develop a software project, is it? They can go for industrial extreme programming. What are the values of extreme programming? Why extreme programming became popular? And why it is used by the agile software process along with agile software process model by software engineering team? Because extreme programming having some features and some values. What are those values? That we'll see here. Beck is one of the scientists who defines a set of 5 values that establish a foundation for all work performed as part of extreme programming. As part of extreme programming, that is communication. Is it? One of the extreme programming value is communication. Second one is simplicity, right? Third one is of feedback. Fourth one is of courage. Fifth one is of respect. These are the 5 extreme programming values. What are the 5 extreme programming values here? So first one is communication. Extreme programming values. What are those here? First one is of communication. Second one is of simplicity. Third one is of feedback, right? And fourth one is of courage. Fifth one is of respect, right? So communication. So in extreme programming values, communication. Through communication, clients will give the requirements in the form of stories. That's it. Clients will give the requirements in the form of stories, and those stories, requirements will be prioritized. Some values will be given, right? That is what the importance of communication. Through communication, requirements will be given by the client to the development team. Simplicity. The development team has to develop a software system based on the current need. They should not consider future needs. With current needs only, with current needs only, they have to design a software system. The designers will designing a software system by using extreme programming, is it? When they are designing a software system, they have to designers, they have to consider only current needs of the project, current needs of the client, current needs of the client. They should not consider and they should not design a software system, is it, by considering future needs. Only current needs they have to consider. That is what the importance of simplicity. Coming to feedback, once the design is done, right? So feedback of the design model of the software system can be collected from 3 forms. First one is from the application, from the developed application, Through developed application, feedback can be collected. Through customer, feedback can be collected, as well as here through the software engineering team, software engineering agile team, because they are using agile process model, software engineering agile team. So there are 3 sources of collecting the feedback. Is it clear? The developer product feedback can be collected by using in extreme programming. Is it? Through developed application, feedback can be collected. Through customer, feedback can be collected. Through agile team members who are involved for development of software system. So that's why this extreme programming became popular. So generally, so far, various software process model we saw, the feedback can be collected only from customer, client. Whereas coming to extreme programming, feedback can be collected from 3 sources. Is it? First source is of what here? Developed application. Another source is of customer, and another source is for agile team members who worked with the software system, right? So these are the values of the extreme programming. These are the values of the extreme programming, right? feedback, just now we had discussed, implemented software itself, the customer, and whom here, the other software team members, agile team members. Each of these values is used as a driver for specific extreme programming activities, actions and tasks. Extreme programming process. So extreme programming process, which consists of planning. So planning of what here begins with the listening, a requirements gathering activity, gathering requirements from the client, right? And listening leads to what here? Creation of a set of stories. Stories is nothing but what here? Client requirements, right? And each story is similar to use cases. Just now we saw what is use case. Here is client or user or actor. This is what the use case, which is giving set of sequences of operations which are performed by a software system. It's called a use case, right? So here leads to the creation of set of stories. Each story is similar to use cases. So the client requirements can be represented in the form of use cases. Means client expecting these are the functionalities from the software system. That is what use case diagram purpose, which represents the functional requirements of the software application. So from software application, what are the functionality the client or user is expecting? What are the functionality the client or user is expecting? That can be represented with use case diagram. That can be represented with use case diagram. Next is of design. Is it CRC? CRC stands for Class Responsibility Collaborator. CRC stands for what here? Class Responsibility Collaborator. Identifying and organizing the object-oriented classes. The purpose of CRC is Class Responsibility Collaborator, which is going to identify object-oriented classes. So why object-oriented language became popular? The entire software system can be modeled, that is in the form of objects and classes. The size of the object and class is what here? Small in size. So that objects and classes can be easily designed, easily developed, easily testable, easily replaceable, easily reusable. These are all the advantages with object-oriented classes as well as objects, right? So extreme programming is using in design what here? CRC, object-oriented. Is it CRC? That means to say identifying, modeling a software system, designing a software system that is in the form of object-oriented classes, right? And coding. So based on the what here design, source code can be generated here. Before going to perform coding, unit testing will be take place in release. Unit testing, we know what is meant by unit, small piece of software source code, and performing testing process, identifying errors from small piece of software source code. So multiple units, multiple small pieces of source code will be tested individually. Later those will be integrated, right? And release the software increments. Next is of testing. So we know after code generating source code, testing process, testers they will perform testing process, they will identify all those errors. Extreme programming process here. Let's see here, extreme programming. So which consists of phases here. What are those phases here? Extreme programming which consists of phases. What are those here? Extreme programming. Extreme programming phases. Extreme programming phases. What are those various extreme programming phases that we will list out? First one is of planning. Second one is of design. Third one is of coding. Fourth one is of test, right? So what is importance of planning? Under this planning phase of in extreme programming, user stories. What is meant by user stories here? User stories are nothing but client requirements will be gathered, right? Client requirements will be gathered, and gathered requirements should be given values here, priorities. Which requirement should be given high priority value, and which one given next priority, which requirement should be given low priority. That is what values. Acceptance test criteria and iteration plan. So how many iterations are required to get the complete version of the software system, that will be planned in this planning phase, right? So once the requirements were gathered, and here use case scenarios were built here, like what are the exactly this developed software system going to do, what are the functionalities to the user that's supposed to be represented in the form of use case scenarios, use case scenarios, right? Based on that here, simple design will take place. We know what is meant by simple design. Simple design represents what? Simple design represents what? What is meant by simple design? So when the designers they are designing a software system, right? They have to consider only current needs of the client. They should not consider future needs of the client. That is what the meaning of simple design. CRC cards, so class responsibility collaborator cards, so which were used to identify the object-oriented classes, to model a software system, to design a software system, to give solution, right? When the design model is complex, When the design model is more complex, more difficult, in that case, they have to build spike solutions, means building prototypes. Was it? And the prototype is supposed to be validated immediately. And that's it. And is any improvement required? Again, the prototype is supposed to be improved. That is what the purpose of spike solutions. If the design model is more complex, is it? Spike solutions supposed to be identified. Means building prototypes for the complex design model. Was it? So through prototypes, what is the problem involved in it? That will be identified. That will be improved. That is what the purpose of that's what the purpose of spike solutions or prototypes, right? Prototype is nothing but initial version of a software system. The design is the complex design model. That's it. Build the sample prototype of that particular design model and identify what is the problem with this. And again, go for second building up second iterative prototype, third iterative prototype, fourth iterative prototype, and fourth one might be complete version. That is considered as final version, right? Based on that, coding will take place, source code generation. Refactoring is nothing but improving the source code. Is it? Improving the quality of the source code. By improving the quality of the source code, by changing the internal structure of the source code, which the behavior of the source code should not change. That is what we call it as refactoring. Pair programming. So what is here pair programming? Why the name given programming? Pair programming. So far, the programmers can generate source code. Only single programmer they can generate source code, right? Whereas in pair programming, whereas in extreme programming, pair programming will take place. Not only one programmer here, two programmers will be involved for generation of source code, for generating source code. Two programmers will be involved. Two programmers will be involved for generation of source code. Two programmers. So two heads are better than one head. That means to say two minds, two people, they are thinking and they are generating source code. One programmer is generating source code. Another programmer is what here? Observing the standards of or whether the generated source code is following standards or not. So that's why pair programming plays major role in extreme programming. And continuous integration. Those developed components supposed to be integrated. That's it. And here unit test will take place here. Right? Testing. So once the source code is generated, testing will be performed, errors will be identified, and prepare the report that is given to the whom here, developers or programmers. They'll perform debugging process. Now the application is error free. They'll release software increment, project velocity. Is it computed? Project velocity computed means here how many client requirements which were implemented, how many client requirements which were implemented. That is what project velocity computed, right? So this process will continue, right, till the final version release of the software system which was satisfied by the client. So this is about extreme programming. Thank you.